Today we're going to repair a plug-in machine. The issue with this machine is that after powering it on, the indicator light doesn't turn on and there's no output. From the outside, there doesn't appear to be any damaged components, so we'll go ahead and connect it to 220 volts to check it. Alright, after powering it on, there's no response at all. Let's take a look at the current flow. First, the 220 VAC passes through these 4 diodes for rectification, then goes to this large capacitor for smoothing. This large capacitor will produce a 310 V DC voltage. The 310 V DC then passes through the primary winding of the transformer, and after that returns to the power management chip. This power management chip is a chip with a built-in switching transistor. After passing through the chip, the current flows back to the negative terminal of the large capacitor, thus forming a complete circuit. Let's flip it over and take a look. These 2 pads here are the positive and negative terminals of the large capacitor. This is the negative terminal and this is the positive terminal. The 310V current flows from here, then goes to the primary winding tap of the transformer, enters from here, exits from this tap, and then returns to the power management chip. After passing through the power management chip, the current flows back to the negative terminal of the large capacitor, thus forming a complete circuit. Let's look at this transformer. There are a total of 3 windings. These 2 are the primary windings and these 2 groups are the secondary windings. First, let's check whether this large filter capacitor has 310 volts. If there is 310 volts, we then check whether the filter capacitors of these 2 secondary windings have voltage. If these 2 capacitors have voltage, then the chip and the transformer are functioning normally. Alright, let's take a measurement. Let's measure this large filter capacitor to see if it has 310 volts. We can see that it has a voltage of 320 volts, which means there is no problem here. At this point, we continue measuring further. We can see that the filter capacitor of this group does not have any voltage, so now we need to trace the issue further upstream. We can see here that there is about 12 volts, which indicates that the chip's drive circuit is functioning properly. Now we continue to investigate where the problem might be in this group of windings. Alright, as we measure again, we find that this diode is already conducting. Let's remove it for further inspection. Okay, this diode has now been removed. Its model is SR2100. After checking, we find that it is a Schottky diode with a rated current of about 2 amperes. Let's use a multimeter to check its condition again. Alright, we can hear that it is still in a conducting state, which indicates that this diode has indeed been damaged and is now shorted. Since this diode is a Schottky diode, we can't use a regular diode as a replacement. Because I couldn't find the same model of Schottky diode, I found a fast recovery diode from this charger board to use as a replacement. Alright, the diode has been replaced. Let's power it on and test it again. Okay, let's power it on and test it once more. Great, as you can see, the water bar is now powered on. Just reset it and it will be fine.